Okay, well, this is lesson 4 of chapter 4, and we're going to be writing linear equations in standard form. So we have done slope-intercept, we learned about point slope, and now we're just going to be doing standard. Okay, just to be familiar with the term standard form. You won't use standard form a ton, but you do need to know what it is and how to kind of work with it. So, just to refresh your memory, um, remember standard form? I hope that you do. Okay, it's ax plus by equals c, where a, b, and c are numbers, are real numbers. That's why they're capitalized. And your a and b are not both 0. Okay, you can't have 0x and 0y. You would then just have a c. So it's kind of like an example would be, let's see, 6x, if we can, sorry, 6x plus 2y equals 12, something along those lines. That would be an equation, a linear equation written in standard form. We could manipulate this around and we could get it into slope-intercept by solving for y. Okay, so all linear equations can be written in standard form. All right, so the first example we're going to do is we're going to talk about writing two equations in standard form that are equivalent to this equation right here, 2x minus 6y equals 4. So this is already in standard form. And what they're wanting you to do is write another equation that's equivalent to that. Well, to write an equivalent equation, if we're going to keep the equation the same and keep it equal to each other, you can multiply each side by 2. Now what that means is, again, what we do to one side, we have to do to the other side, and that keeps it equivalent. So here's like an example. We could take this 2x minus 6y equals 4, and we can multiply, like I've said before, we can multiply the entire equation by 2. And that's what they did here. They did 2 times 2x to get the 4x, 2 times negative 6y to get the negative 12y, and then 2 times 4 is 8. So basically it's like multiplying the entire equation by 2. We're multiplying this side by 2 and this side by 2. That's kind of what that means. So another option we could do to write an equivalent equation, I always like to try to keep it easy, is we can multiply each side by a negative 1. Just change the signs of everything. So again, it would be like taking our original standard form equation and multiplying the entire equation by a negative 1. So we would get negative 1 times 2x, and negative 1 times negative 6y, and then negative 1 times positive 4. And this is what we would get. We would get a negative 2x, a positive 6y, and a negative 4. Notice all the signs just change. The signs of every term. This changes to a negative, this to a positive, this to a negative. That is just one easy way to write an equivalent equation. So all three of these equations you see are all equal to each other. They would all graph the exact same line. All right, example 2. Writing an equation given a point and a slope. Now, we've already talked about this. If you're given a point and a slope, normally we do write point-slope formula, which is what we're going to do, because we know a point and we know the slope. That lends itself to point-slope. Okay, so we're going to use the point-slope formula. Here's our point, and here's our given slope. So we're going to use the point-slope. So we did y minus 2 equals, and then notice there's no m out front because it's that understood 1. Since our slope is 1, we have an understood 1 out front for our slope. And then we have x plus 3 because x minus a negative 3 makes it positive. This is just what we did the last couple of days, point slope. Okay, so we're going to use that, and we're going to, this is what they've done here. It sounds confusing. I'm going to take that 1 away just so you can see. We are getting the x and the y. We're going to move the x to this side so that we get the x and y on this side. And we're going to move the 2 to this side so we get the constant on this side, or the c. Okay? So we subtract x from this side and subtract x from this side. Then we add 2, which is what they're doing right here, and adding 2. So that's what they're doing. That's why they've done that. Because we want the x and y on the same side, and we want the constants on the other side. So that leaves us with, these cancel out, so it leaves us with negative x and a positive y, negative x plus y. These cancel out, and 3 plus 2 is 5. So there is our equation in standard form. Okay? They did it in 1 step. You can do it in 2 steps if you need to, but I highly suggest you do the actual writing. Even if you do it in 1 step, write this down so that you can see what's going on each side. Okay? All right, here we go. Next example. Write an equation from a graph. So they give us a line. We can obviously figure out the slope of the line by going down and over, and we have a point for our point slope. So they're going to use slope formula. They're going to calculate the slope with slope formula. We could always calculate it this way. We're going down 3 and to the right 1. So my slope is negative 3 over 1, which is what they have shown. Negative 3 over 1, so my slope is just negative 3. Again, they're going to use point slope using this nice easy 1, 1. That's just the easiest point to use. And there's our point slope form. Again, substitute your points in. Substitute the 1 in for y sub 1, the negative 3 in for their slope, and the 1 in for your x sub 1. And simplify. And we're going to rewrite the equation in standard form. So here, let's go back. I want to do this for you. We're going to go back. Okay. Y minus 1 equals negative 3 times x minus 1. Okay. So y minus 1 equals negative 3 times x minus 1. So let's go ahead and work this through just so you can see. This side is going to stay y minus 1, and I'm going to distribute this in right here. Okay? So I get negative 3x, and then negative 3 times negative 1 is positive 3. Okay? So now I need to get my x over here and my negative 1 over here. So I'm going to add 3x to both sides. I don't have any x terms, so I'm not going to put it underneath anything because there's no x's here. And I'm going to add 1 to both sides. My 1's cancel out, and on this side I have 3x plus y. And on this side, my negative 3x and positive, that's a positive 3x, cancel out. And then 3 plus 1 is 4, and I believe that is what they show as the answer. 3x plus y equals 4. Okay, so very similar. We're using point slope form, and all we're doing is taking that point slope form and manipulating it around. That's a lot of what this is just manipulating equations, moving things from one side to the other and understanding how those work. All right, this is example 4. They're going to have us write a specific equation. Okay, you guys know this. The blue line right here is a horizontal line. It passes through what point on the y-axis? 1, 2, 3, 4. It passes through this right here, negative 4. So, since it's a horizontal line, the y-coordinate is negative 4. This means that all points on the line have a y-coordinate of negative 4, as you guys can see if you look at all the points. So the equation is y equals negative 4, which we know that. A horizontal line is going to be y equals something. Okay? The vertical line is going to obviously be an x equals something. Well, our x-coordinate is 4. So all of the x-coordinates are 4 on this line. So my equation would be x equals 4. So there are your two. That's pretty simple. Okay? If they use the same point, if they drew a line through here and said, what's the equation? I'm so sorry, I'm bad at lines. If this was a straight line and it passed through at x equals 2, the equation for this line would be x equals 2. So we could just, like, our y-coordinate becomes our line for our horizontal, and our x-coordinate becomes the value for our line for our vertical. Okay? All right, so last example. This is very similar to like finding b. Find the missing coefficient of a line with an equation of ax plus 3y equals 2. So if we know of a line or an equation like this, we are not sure what the coefficient of x is, but we know it passes through this point. We need to find out what that missing coefficient of a is. So first, to find the value of a, substitute the coordinates of the given point in for x and y. We don't have to worry about slope because there's no m in this equation at all. There's no m. So substitute the coordinates in for your x and your y, and then solve for a. This is kind of like solving for b in our slope-intercept form, except we don't have to substitute in slope. So here's our example. Write the equation. There's what we're looking for, is our a, right here. That's what we're looking for. So we're going to substitute the -1 in for x and the 0 in for y. Okay? Everybody see that? There's my x coordinate right here for x. Here's my y coordinate right here for y. And when I simplify this, I end up with negative a, because a times -1 would just be negative a. 3 times 0 is 0, so that kind of disappears. So I get negative a equals 2. Well, I don't want negative a. I need to know what positive a is. So if negative a is 2, then positive a would be -2, or divide both sides by -1. Okay, so my a is -2, so therefore I just go back and put that in for my a, and there is my correct equation. I just substitute what I solved for a. A had to be -2, so I put that in for a. My x and my y go back to being an x and a y, because I do want this to be a standard equation, a standard linear equation. All right, you can stop the video and do your guided practice. They should correspond with each of the examples.